Bonjour.
Hi
Aujourd'hui, on va
viewers,
faire un
today I
portrait
am going to look at a Pontiac Grand Prix 2002 3.8 liter. The owner complained about the blower fan not working when it is cold and humid. He had the blower fan and the resistor module replaced not a long time ago, but the problem reappeared lately. Since these parts are quite new, I am going to focus more on the other circuit components. Usually, to find the cause of an electrical problem, we need to check the related wiring diagrams. We also need some tools like a multimeter, an ammeter, a test light, and jumper wires. Because I did not have any wiring diagram during that visual inspection, I only used a test light and jumper wires to check the components. First, I started the engine with the blower fan in off position. The car started perfectly and did not display any check engine signal. Everything was normal until I tried the blower fan speeds. None of them were working, so I turned the engine off. I began my inspection under the hood. The battery poles were clean. The battery cables were in good condition and well connected. The main fuse box connection and the chassis ground connection looked also very good. The other easy inspection under the hood was the fuse box. I checked the maxi fuses and the mini fuses. They were all good, and there was no visible oxidation on the contacts. The other easy inspection was to check the fuses installed in a small compartment behind the glove box cover. The fuse cover had to be removed. I checked all the fuses and I focused on the 3 fuses that are used to power the HVAC components. Still, the fuses were fine and there was no visible oxidation on the contacts. The other visual inspection was the blower fan, the resistor module, and the harness connections that are located just under the dash near the glove box. To be able to remove the resistor module and make some electrical tests, the blower fan harness connector was unplugged. This gave more room to unscrew and remove the resistor module. Because the blower fan and the resistor module were quite new, I only inspected in detail the contact pins and the contact sockets. I even dismantled the connector, but I saw no oxidation. Anyway, I cleaned the contacts and I reassembled the connector. Since I had the resistor module uninstalled, I wanted to test the speeds 1, 2, 3, and 4 with a known good battery voltage. I used 3 jumper wires to test the resistor module and the blower fan together. I tried the speeds 1, 2, 3, and 4 separately, and they worked perfectly. The process of elimination was working fine so far. The owner and I noted that the daytime running lights were not functioning when the fan was not running. I also noted that when the car started with the blower fan set on speed 5, the fan was running fine. Because I had no more time to perform another test on the car, I reassembled all the parts. I still had the ignition switch and the blower fan speed selector on my checklist. Those were good keywords for a web search over the weekend. I made my research with the keywords GM ignition switch and daytime running lights. I also found some wiring diagrams about the ignition switch and the blower fan circuit. It gave me good basic information to complete my own electrical drawings. On the wiring diagrams that I found, the blower fan, the daytime running lights, and the other components were all connected on the orange wire going to the ignition switch. This explains why these components were failing when they were used together. On some internet forums, it was mentioned that the ignition switch was the problem and it had to be replaced. A certified auto mechanic should check if there is low or no current flow in the orange wire due to high resistance on the ignition switch contacts when the circuit is loaded. Without sufficient amperage, the blower fan may not work in speeds 1, 2, 3, and 4. With the ignition switch and the fan switch on off position, the orange wire and the red wire are temporarily connected together with a jumper wire. Then, when the engine is started, the fan speeds can be tested. If the blower fan speeds and the daytime running lights are working fine, it is possible that the contacts in the ignition switch are heavily oxidized. The jumper wire should be disconnected with the ignition switch on the off position and the fan switch on the off position. The ignition switch should be removed, inspected and replaced with a new one if needed. Because I did not have an original wiring diagram, I recommended to my friend to go back to the garage where he had his blower fan installed. I gave him my documentation about the bad ignition switch and I told him about the loss of power on the orange wire. My friend went back to the garage during the week and the auto technician confirmed that the ignition switch was bad. The ignition switch was replaced. Later, my friend tested the car and everything was working perfectly. I asked him to give me the old part so I could open it and check the contacts. In the following days, I was given the ignition switch assembly. It was time to inspect it. I started by removing the retaining ring. After, I unclipped the spring cover. The 6 springs that you see are used to push on the movable contact plates. To access the contact plates, I had to remove the plate cover. I used 4 small metal blades and a small screwdriver to unclip and lift the cover. I carefully removed the cover and I slowly removed the plastic cylinder to make sure the movable contact plates stay in place. When I undid the switch housing, I could see that the movable contact plates sat on the groove of the stationary plates. Once the movable contact plates were removed, it was easy to see the feed side and the load side of the stationary contact plates. Here I show all the parts and how I made this setup with my magnifier to be able to see the ignition switch contacts in detail. I did not find a specific parts list on the web, but I made my own one to identify my parts. Now let's look again at a good contact surface on a movable contact plate. I use my camera and a magnifier to make close-up views of all the contacts. I took these pictures to prove that the contacts that carry heavy current loads have a lot of oxidation and pitting. Because of heavy-duty servicing and long-time wear, you can see that the contacts for the blower fan and the accessories are heavily oxidized and carbonized when compared to a low-amperage circuit. These damaged surfaces got worse day after day, causing more resistance and overheating contacts. Also, look at the bad starter contacts. They were ready to fail at any time. This is another good reason why the ignition switch had to be replaced. I hope that you like this presentation and that my illustrations will help you to solve your blower fan problems.